This is the video that will review solving systems of linear equations by graphing. So we did this today in class, but I just wanted to do a couple of examples here so that you have something to go back to in case you were struggling in class today. So I chose number 6 from your notes to look at because it has two linear equations that are written in different forms. So notice the first equation is written in slope-intercept form, which should make your life just a little bit easier. So for that first equation, since it's y equals x plus 5, what you should already know is that you can graph your y-intercept, which in this case is 5. That's our b equals 5. So I'm going to go ahead and put a point on 5 on the y-axis. So 1, 2, 3, 4, 5. So I am going to put a point right there on positive 5. And then since this equation has no coefficient in front of x, I know that my slope is 1. So I'm going to rise 1 and run 1 and put another point. Now I would suggest doing that process a couple of times just so that you have a nice straight line whenever you go to draw your line. Because remember, in a system of linear equations, you're looking for that point of intersection. So you want your line to be nice and straight so that you can see where those lines are intersecting on your coordinate plane. Okay, so that is my first line. That's this one right here. Then to graph my second line, there's two ways that you could do this. So notice that this line is written in standard form. That's when x and y are on the same side and then c is all by itself over there. So I could rewrite this in slope-intercept form, which seems to be like what you guys like the best. So that's what I'm going to do. If I have x minus y equals 2, the first thing I want to do is get x to the other side by subtracting. So I'm going to subtract x from both sides. That's going to cancel, and I'm going to bring down my negative y, and that equals negative x plus 2. Then the next thing I'm going to do is divide everything by negative 1 because I want that y to be positive, and that's going to divide both of these things by a negative. So a negative divided by a negative makes that positive x, and positive 2 divided by negative 1 makes that negative 2. Then from here I'm going to graph the same way. So here is b. I know that b is equal to negative 2 in this case. So I'm going to go to negative 2 on the y-axis, and I'm going to put a point. And then here, once again, since my coefficient of x is invisible, it's like an invisible 1, so my slope is 1 over 1. So I am going to rise 1 and run 1 and put a point. Now at that point, what you probably should be thinking is, I have two lines with different y-intercepts, but they have the same slope. So if I have two lines with the same slope, but different y-intercepts, then I have parallel lines. And if they're parallel, they're never going to intersect. And if they never intersect, then this solution would have no solution. Remember, the solution to a system is where the two lines intersect. So if these two lines never intersect, then this solution would be no solution. Okay, so this is number 8 from your notes. We're going to start the same way. So when I look at this first equation, I notice that it is x equals negative 2. And when I see x equals negative 2, I automatically make myself a note that this must be a VUX. Remember, VUX stands for vertical line, undefined slope, and that's x equals a number. So when I see x equals, I know I've got that vertical line. So I'm going to go to where x is equal to negative 2, and I'm going to put a point, and I'm going to draw a vertical line through that point. Then I'm going to look at my next equation. I have 3x minus 2y equals negative 18. Now on the last slide, I changed both of the equations to slope-intercept form. But on this one, I'm just going to graph it using my intercepts. So that's also another option that you have if your line is written in standard form like this. So to find my y-intercept, I am going to cover x, and I'm only going to look at y. So when I cover x, I notice that I have negative 2y equals negative 18. So if I solve for y by dividing by negative 2, I know that y would be equal to 9. So that has to be my y-intercept. So I'm going to put a point on positive 9 on the y-axis. Okay? Then to find my x-intercept, I'm going to cover up y and I'm only going to look at x. So now I have 3x equals negative 18. If I was solving for x, I would divide by 3 and I would find out that x is equal to negative 6. So I am going to put a point on negative 6 on the x-axis. Then you need to take something straight and you need to draw a line through those 2 points. Now, remember, the solution to a system is where those 2 lines intersect. So those 2 lines appear to intersect right here, where x is equal to negative 2 and y is equal to 6. So you can check your solution just to make sure. So it appears that my solution is at negative 2, 6. Well, if that's a solution, then that means it has to work in this equation. So I'm going to check and just make sure that it does. So if I have 3 times negative 2 minus 2 times 6, is that going to equal negative 18? Because that's what my equation says it should equal. So 3 times negative 2 is negative 6. Negative 2 times 6 is negative 12. And negative 6 minus 12 is equal to negative 18. So I see that this ordered pair does work in my equation. Now, it also has to work in the other equation. Well, that one's a little bit easier because it was x equals negative 2. Does x equal negative 2? Yes, it does. So I know that that is the solution to my system. So remember, the solution to the system is the point at which the 2 lines intersect. So I was looking for this point right here. It's really important that you graph your lines and they're very straight and you're being very meticulous about your graphing so that you can see where those 2 lines intersect. Okay, we will work on this again tomorrow in class. If you have any questions, make sure you ask tomorrow or you can email me tonight. Y'all have a great evening.